observable from certain locations on Earth by professional and amateur astronomers, and the results webcast over the Internet. Mission images will be analyzed, and together with the knowledge gained by Discovery's other comet missions, will contribute to a better understanding of the solar system's formation and the implications of comets colliding with Earth. Ions from the Sun and the Moon are targets for 2 other Discovery missions. After a 5-day transit to the Moon, Lunar Prospector, Discovery's 3rd mission, began a 19-month global study of the Moon's surface, providing insights into lunar origin and evolution, while also attempting to determine whether water ice is present in the Moon's polar regions. A wealth of data collected by the 5 spacecraft instruments from a near-circular lunar polar orbit of 100 kilometers above the surface has enabled scientists to create the most detailed maps of the Moon's gravity, magnetic properties, and chemical composition. Upon completion of its mission in July 1999, scientists targeted the spacecraft for an impact inside a shadowed crater near the lunar South Pole. If water ice existed on the Moon's surface, the impact would free up water vapor that might then be detectable from Earth-based observatories and the Hubble Space Telescope. Although the controlled crash produced no observable evidence of water, analysis of neutron spectrometer data confirms previous indications that hydrogen at the lunar poles is in the form of water ice. Lunar Prospector has given scientists tremendous new insight into Earth's closest celestial neighbor, the Moon, and provided a greater understanding of solar system origins that has expanded our horizons.
NSC report, spacecraft is go.
Genesis is go for launch.
We have ignition, and we have liftoff of NASA's Genesis spacecraft on a mission to retrieve a piece of the Sun.
Scientists generally believe bodies in our solar system formed 4.6 billion years ago when interstellar gases, dust, and ice randomly came together. Outer layers of the Sun today are composed of nearly the same material as when it was first created. What if we could capture pieces of this solar material and study it here on Earth? That is the goal of Genesis, a mission to collect ionized gas from the Sun called solar wind and then return it to Earth. Mission scientists hope to learn what the Sun is made of and if the planets are made of the same materials. For 26 months, Genesis will orbit 1.6 million kilometers from Earth at the L1 libration point, where the gravitational forces of the Earth and Sun are balanced. Genesis will collect ions from the solar wind on specially designed high-purity wafers. At the mission's end, the spacecraft will return to Earth, sending the sample return canister down to the Utah Test and Training Range to be captured by a helicopter in midair to prevent any damage to the precious cargo. The Genesis samples will be the first solar system material returned to Earth since Apollo. The samples will be stored and cataloged under ultra-pure cleanroom conditions in a facility built especially for Genesis at NASA's Johnson Space Center. Genesis will provide a supply of solar matter for 21st century science research to enrich our understanding of the birth and evolution of the planets and other bodies in our solar system. 3 Discovery missions target planets: Mars, Mercury, and a search for Earth-sized planets orbiting other stars. With NASA's first return to the Martian surface in more than 20 years, Mars Pathfinder performed science experiments on the surface of Mars for nearly 3 months, achieving its primary objective of demonstrating a low-cost method of delivering a set of science instruments and a small rover to the surface of the red planet. Rock and soil samples at the landing site were analyzed, atmospheric and weather conditions were monitored, and Pathfinder conducted the first astronomy studies from the surface of another planet. After a 6-month journey, a unique engineering design sent Pathfinder through the thin Martian atmosphere, descending to the surface of Mars, using an innovative system of parachutes and retro-rockets to slow the lander. And then, shrouded with an inflated beach ball-like airbag, free-falling for the last few hundred feet, bouncing as high as a 10-story building due to the low Martian gravity. Once deflated, the airbag opened a path for the Sojourner rover to explore and analyze nearby rocks. Mars Pathfinder returned more than 16,000 images from the lander and 550 images from the rover. The science teams analyzed extensive data about the planet's geology, magnetic properties, mineralogy, and geochemistry. The new information about the Martian interior will help scientists to understand how the red planet has evolved over billions of years. Mars Pathfinder has played a crucial role in advancing NASA's long-term plan for Mars exploration and other Discovery planetary journeys. Almost 3 decades have passed since Mariner 10 flew by the planet Mercury on a mission that mapped only 45% of the planet's surface. Discovery's lower-cost Messenger mission will continue the legacy of Mariner 10 with a comprehensive scientific investigation of the solar system's innermost planet. During its 5-year trip to Mercury, Messenger will perform 2 gravity-assisted flybys of both Venus and Mercury, collecting atmospheric and gravity measurements of Mercury along the way and capturing never-before-seen images of the planet. In September 2009, a second mission phase begins. Orbiting for 1 Earth year or 4 Mercurian years, the spacecraft will globally map and perform a detailed characterization of the surface, interior, atmosphere, and magnetosphere of the planet. The spacecraft's 7 miniaturized instruments will collect data to answer key scientific questions about the origin of the planet's high density, the composition of its crust, the existence of volcanism on the planet, whether hydrogen in water ice exists in the polar caps, and if a liquid outer core is responsible for generating its Earth-like magnetic field. Messenger will provide an understanding of the thin Mercurian atmosphere, its dense rocky geology, and the forces that have shaped Mercury, all fundamental to understanding the terrestrial planets and their evolution. Exploring the evolution, structure, and diversity of planetary systems is the goal of Kepler, a Discovery mission to search for Earth-sized planets around stars in our galactic neighborhood. Using newly developed technology, the mission expects to detect hundreds of planets in or near the habitable zones surrounding stars. Detecting extrasolar planets from a very stable heliocentric Earth-trailing orbit around the Sun, Kepler will observe habitable zones in regions where water can be expected to exist in liquid form, increasing the probability of life. Kepler will greatly increase our understanding of planetary formation, the structure of individual planetary systems, and the generic characteristics of stars with terrestrial planets. The Kepler mission may help us answer one of the most enduring questions humans have asked throughout history. Are there others like us in the universe? NASA's Discovery program has achieved groundbreaking science within strict cost and schedule caps.
I believe I have a firm signal.
The President and I are both very, very proud of your accomplishments, and the entire country is just reveling in your success, and we all congratulate you.
Discovery is demonstrating that simple, focused missions can pay rich dividends while driving new, innovative technology with the ultimate prospect of improving life on Earth. Discovery is unlocking the mysteries of the solar system.